Thank you for coming. My name is Tim Clevenger. This is access control done right the first time. By day, I'm a network cybersecurity engineer, but in a previous life, I worked as a sysadmin for an alarm company that did access control systems, and they offered to let me get out of the dark server room and go drive a truck around and install, troubleshoot, maintain access control systems that had been installed by them and by other companies. And so working on those systems, I just came up with a few kind of tips and tricks to make your access control system, whether you're installing a new one, upgrading, or just doing maintenance, make it a little more maintainable, a little more reliable, a little more secure. Many vendors, it's a low bid situation, and they'll sell you a minimal viable product. It'll work, it'll probably open the doors, but it's usually not the best for your long-term security, I would say. So when you're choosing a system, there's a company called Mercury Security. They make the majority of the equipment that is in use in the industry. There's a bunch of companies that will take that equipment and put their name on it. It has local storage and onboard processing, so the access panels make all of the decisions on whether to open a door based on the cardholder information. So if your power goes out and comes back on, you don't have to worry about the board losing its memory and having to reload it, unlike some other vendors that are out there. The cool thing is because it is firmware reflashable and everybody uses the same boards, if you decide, for instance, that you're not going to use Linnell anymore and you want to go with a Genetec or a Honeywell, you can have them come reflash the firmware on most of your boards and be able to switch over to another system without having to buy a whole lot of extra equipment. So this would be a good time to have video, but I have pictures of a couple boards here. So there's essentially two boards that you'll find in the field. One of them is called the access panel. Again, this is the board that makes the decisions, or most of the decisions, about whether to let somebody in a door. They're typically connected to your network and to your server over Ethernet. They have a two-door controller built into them as well, so if you only need two doors, you can get away with just a single board. And then you have what's called a door controller, and these are dumber boards. They're a lot cheaper, but they don't store a copy of the cardholder database. So if something happens and they lose connection, they go into a really dumb mode where it's either everybody's allowed, nobody's allowed, or only people with a certain facility code are allowed, even if they left the company 10 years ago and didn't turn their card in. The way that, and here's another good time for a picture. So a typical installation, you'll have an enclosure mounted to a wall somewhere. You'll have your access panel, again, connected with Ethernet, and then you'll have one or more door controllers connected to that. And then you'll have a power supply with a charger built in and a couple of batteries so that if the power goes out, you're still able to open your doors. So first thing to consider when you're looking at an access control system and you're working with a project manager at the company or you're putting out an RFP is, where in my building am I going to place my equipment? So some considerations for that would be like environments, heat, humidity, and dust. I had to go to work on a system for an HOA and replace the board in one of their pools, their common pools, because it wasn't working reliably. And when I opened the door, it's all crusty because they put it in the same room that they put their saltwater pool filtration system. You're not going to warranty that board. You're going to have to buy a new one. Power availability is another one. Obviously don't just plug it into an outlet. You want something that's hardwired with its own circuit breaker. Physical security, is this going to be in a hallway? Is it going to be in a closet where maybe unauthorized people are going to get in there? Maybe put a lock on there and a tamper switch so that it's easy to protect it from somebody just opening the door and tearing out wires. And then future accessibility. A lot of times you'll find remote equipment that has been installed by the vendor and they just stick it up in the ceiling, and then later it gets drywalled over and then there's wallpaper, and if you have to get to that, you're going to pay somebody to have to fix that up. So when you're making that decision, I'm going to talk a little bit about wiring. So you have wiring from your access panel, which again makes all the decisions, to your individual door controllers. So door controllers, that communication is done with a protocol called RS-485. It's a protocol from the 80s. It's typically a 2-wire or 4-wire cable that connects from the panel to the door controller. There's a shield that has to be drained at one end, and then there's termination at the end of a string. The theoretical distance is 4,000 feet. So the first thought from any vendor is, oh, we'll just put a panel here and then we'll just run 4,000 feet of wires to all of these door controllers. The problem is they're daisy chains. So you go from your panel to your door controller to your door controller to your door controller. If that wire gets cut in the middle or there's electromagnetic interference because somebody's put a transformer on the other side of the wall, you lose the entire string, and then you have to troubleshoot where in all of these devices in this long line of thousands of feet is the problem that's causing me to lose access to all 31 of my door controllers. So one fault anywhere in there, and that could also be in a failed door controller that's causing problems on the line, can cause a real issue. Then you have to think about the wiring from that door controller to the actual doors. The card reader wiring also uses RS-485 for newer installations, so there's some consideration there. But also you have kind of power-hungry locks like magnetic locks or crash bars that can use a lot of electricity, and then you're putting a remote power supply out there. So you kind of have to decide where in my building can I minimize all of these issues. And then also wire quality. So typically what I see is a lot of kind of whatever was on the truck or whatever we got at a discount from the place that we buy our wire is going to be what we're going to use. So, the power to our door lock, well, it's a little far for this 18 gauge wire, but we're going to go ahead and run it anyway because that's what we've got. I've seen spliced wire where they've just kind of, they ran out of wire or something and they spliced it together, or maybe it got cut or something. A lot of unshielded wire, again, for card readers, this is particularly an issue where the card reader can crash and you actually have to unplug it from the panel to get it to start working again. And then just plain unsuitable wire, like I've seen Ethernet wire used for wiring this stuff. So the answer to that is called composite access control cable. It's made by companies that design this for access control applications. It has all the wires that you need. They're all shielded where they need to be shielded. You can get them with auxiliary and spare conductors if you want to run a push button or other stuff. They're properly shielded, as I mentioned, and then there's like a thick exterior jacket. But the important thing is, if somebody has run this access control cable, you can look at it immediately and go, okay, this is suitable cable. I don't have to go figure out, did they run too thin a cable for this particular wiring run. And again, a little bit about those remote power supplies. They're required for power-hungry locks. Magnetic door locks are the worst for this because if you get too much of a voltage drop, then somebody can just pull on the door really hard and it'll open, but it looks like it's locked. And what'll happen is sometimes they'll run wire and they'll realize, oh, this is too far. We're just gonna put a remote power supply up in the ceiling somewhere above a conference room, maybe above the door, not necessarily tell you that it's there. And then when the power goes out and that one door doesn't work, you have to figure out why it is. And they'll use the cheapest enclosure, the cheapest power supply. They won't put batteries on it. It won't have a tamper switch. So again, it's something that when you're looking at your layout with your project manager, you can go, okay, this looks like a really long run. Am I going to need to do a remote power supply? If so, let's pick the model and everything right here and make sure it gets batteries, make sure it gets documented, make sure it's someplace where, again, we're not going to have to tunnel through a ceiling to get to it. The preferred layout, at least in my opinion, having done a few of these, is to kind of cluster your equipment. So you get a large enclosure. Hey. All right. Hi, my name is Tim Clevenger. This is Access Control. So this is kind of the preferred way that you want to do this. You want to cluster your equipment into a single enclosure or a couple of enclosures near each other. You have your access panel at the top, you have door controllers, and you run all your door wiring out from there. The nice thing about this is all of your RS-485 wiring, well, in this particular enclosure, it's pre-wired, which is even better, but it's all nice short runs. If something happens in here, it's real easy to troubleshoot because it's all right there in one place. So typically in an office scenario, you're going to have, this is like a Class A office in a high rise where you have essentially two halves of a building. There's elevators in the middle that are kind of the common area. And so generally, what you want to do is kind of have that cluster just somewhere near the center of the floor. Don't run RS-485 to another floor. Don't ask me how I know. have that kind of centralized there, and maybe you got to do a remote power supply at the far end if this were a much bigger floor. But in a situation like this, again, it's all centrally located. Or, for instance, you might have, I don't know, a pandemic that causes a bunch of folks to work from home, and you've got this extra office space that maybe you want to sublease half a floor. So maybe when you get this space, you plan out, okay, I'm going to do a cluster over here that controls this side, a cluster over there that controls that side, and that way, if we need to sublease it, we can just cut one wire, put up some doors to block off one half of the office space, and then you've still got your half of the office. And if the sublease ever ends, then you just run the Ethernet again to that access panel, reprogram everything, and you're up and running with a whole floor again. Now, there are some cases where you're going to be doing RS-485. So here, for instance, you have like a warehouse with 70, 80, 90 docks, and a person door every 10 docks, so that you have a fire escape and maybe somebody can talk to a driver and go back in. Well, your Ethernet is going to be 328 feet is the maximum that you can go. So you probably are going to have to put your access panel at one end and run door controllers just kind of linearly along the wall above all of these doors with a drop every 10 doors to be able to open that person door from the outside. The wiring's exposed. It's not, there's no EMI, there's no rats up there. It's real easy to troubleshoot and figure out that way. So in that case, you're probably, rather than trying to do Ethernet to all of these and fiber media converters and everything to try to reach 800 or 1,000 feet, just do that single run of RS-485. And then you have the gate way at the far end of the parking lot, and you've got everything in your building all nice and clustered, one or two clusters on each floor, but you've got that gate out there with the card reader. Probably your best bet's going to be RS-485 for that, unless you've got a guard shack that has Ethernet, then maybe you do a panel. But again, you're running it in a conduit underground. You can go up to 4,000 feet. It's one drop because you only need one door controller at the far end. It's going to be much more reliable than, having to do it any other way. So when you're doing these panels in the enclosures, and this goes for remote power supplies as well, you'll find that, again, we're doing this low bid, minimum viable product. These enclosures typically have tamper switches. So if somebody pries open the cover on the thing, you get an alert in your system, and you can send somebody out to go figure out who's opened this up and why. And also, this goes for card readers. There are numerous attacks against card readers, and the first thing that they do is pull the card reader off the wall and attach something to the wires and put it back on the wall. If you have a tamper, at least you know that that's happened. And also for a Knox box where you have a key stored, having a tamper on that, again, just helps if somebody pries it off the wall, immediately and can disable the card or rekey the locks or whatever you need to do there. And typically, they just won't do this connection. So make sure that you have that in your RFP, or when you're talking to your project manager, your salesperson, make sure that you've got that squared away. I want AC fail, I want battery fail contacts, so that if the power goes out for that one panel for some reason, I know about it instead of waiting for the door to stop working. I talked a little bit about some of the better locking hardware to deal with motorized crash bars and multi-point locks, where you have a lock on the top and the bottom. And magnetic locks especially take a lot of electricity. So if you're going to do a long run, you have to look at, maybe I'm going to do a remote power supply. Maybe I'm going to do 24 volts to this instead of 12 volts because I can use the same wire and run essentially twice the power to it. But it's something that you need to consider, because again, a magnetic lock, a lot of times if that thing's got some voltage drop, it'll look like it's locked and it'll rattle like it's locked, but if you pull hard enough, it'll just pop open. And then any doors that have solenoids. I've seen this happen a few times, just kind of standard solenoid unlocked doors. If you have, this door is unlocked during business hours, 8 to 10 or 12 hours a day, you may notice that the handle feels warm. It's because that solenoid is constantly activated during business hours, and it can fail on you, and then you can't open the door at all. So it's just something to keep an eye out for, and make sure you have something that maybe is better suited for that particular door. Motion sensors are used to determine whether somebody is opening the door from the inside legitimately, as opposed to prying it open from the outside. They generally require separate power, so make sure that you're accounting for that when you're running your wire. They have essentially heat or infrared or microwave or both is a way that they detect movement. Aim and detection range is important on these. First of all, because there's bypasses, you can do the spray through the doors or the under the handle door opening, or you can get false trips, which sends a guard out there for no reason. You also have, this thing is aimed at a door, but it's in a hallway, and every time somebody walks by, it goes click, 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 which drives people crazy who are sitting near it. So those door sensors I was talking about, a door contact, so that detects if the door is open or closed, and the REX, or request to exit, that again is a micro switch or a motion detector or even a push button that says this door is about to open legitimately from the inside with somebody leaving. There's bypasses for all of those, so again, kind of think about that when you're deciding what you want to do there. What is almost never done are supervision resistors. These are basically put in line as close to the door contact as possible, and what they do is they change the signal from either this line is open and this line is shorted. It changes it to 4 different resistance levels. This line is shorted, this line is opened, or the door is open or the door is closed. So it allows you to allows the system to detect, again, if somebody cuts the wires or splices them together or the door contact falls off, it helps you troubleshoot that a little bit better. These things are like $1.50. It is sheer laziness that companies do not install these. A little bit about life safety, because that's very important. There's fail-safe versus fail-secure locks. And what that means is, if the software crashes, is this door going to fail safe, meaning that somebody can open the door to get out, or is it going to fail secure, where the door is not going to open? Always make sure that you set that up to allow people to escape. It's never worth risking people's lives to protect property. Coordinate with your local fire code and your authority having jurisdiction. Some areas that's a fire marshal, sometimes it's a building inspector, but make sure that you have a way for people to escape if there's an emergency. If you are in a high-rise building, again, you'll have a building fire alarm, and usually part of your lease and probably part of the fire code is that you connect your system using these relays so that if the fire alarm goes off, it automatically unlocks doors so that people can escape. And then finally, a Knox box, you may have seen these. They're typically attached to the outside of the building. They have a special key that the fire department and probably bad guys have, that they can open it up and get a key or a card out of there to get into a building in case of an emergency. Again, I would put a tamper on that because you really don't know who's cloned that key or who has that key. So a little quick thing about badges and readers here. Badge readers come in different shapes and sizes and strengths depending on where what you're going to be reading. Additional factors, including biometrics and pin entry, are available. I typically love to have pin entry on high security doors, like maybe your server room, because it keeps anybody from having cloned or stolen a badge from immediately getting in, unless somebody wrote the pin on the back of the card. There's different badge types. I only have a few here. The 125 kilohertz procs, those are really trivial to break. Those are the ones you get from your gym and your apartment complex's parking garage. They're the cheapest systems that you can get. The higher frequency I-class ones are also pretty well broken by now. There are some others like the Desfire V2 and above that's maybe not broken. There's some kind of workarounds on some of these. And then the HID CEOS is also not broken. Again, asterisk. So the procs in the I-class, they have a facility code and a badge ID. The facility code, you have 256 facility codes to choose from in the 26-bit format. You can buy the cards from your vendor or eBay or other places with the facility code that you want. For some reason, I've seen more than any other codes, obviously 1, but I've also seen 132 as a code that a lot of people get. So maybe don't get those. Again, procs and I-class, you can clone them. Any compatible reader that you get off eBay can read those cards, and then the data can be captured from a portable reader, like one that you attach to batteries and stick in a briefcase and go get people's cards. The solution for that is custom badges. Again, there's many different ones. These are the ones I'm familiar with. It's called HID Corporate 1000. It's CEOS compatible, so it's more secure. You get a dedicated facility code. Nobody can order that same facility code except for employees, specific employees from your company, from your preferred vendor. And because it's a 48-bit format, you have 8 million badge numbers to choose from. So you can pick a range from way up high and not have to worry about acquiring a competitor, and then you've got the same badge numbers. When you use a system like this, make sure you disable the older formats, otherwise people can still use an old prox. So badge reader communications, Wiegand is the one that's still being used. It's 1975. It's a year older than I am, and it's still being used. Again, very trivial to capture. Pull the reader off the wall, attach one of these devices on there. It'll send it to you over Wi-Fi while you're outside the property. The fix here is tamper switches and OSDP, which is the Open Supervised Device Protocol. It's from 2015. It has encryption. You have to actually enroll your badge readers so that they communicate over an encrypted protocol. Again, it's RS-485. You can daisy chain readers. Please don't. There's only very specific circumstances where you're going to want to do something like that. It's not perfect. There is a compromise possible while you're doing the reader pairing. If somebody on the other side has it's one of those unlikely ones. But the biggest problem is 84% of installers, as of a couple of years ago, never or seldom use it. They're still using the old Wiegand. So what else should I do? Test your readers regularly. Make sure that those are working correctly. Set up alerts in your system. It does you no good to spend all of this money on an access control system if it generates alerts that go nowhere. Have it send an email. If you can't have a guard or somebody responsible for that, just have it send email alerts to a bunch of people and somebody can go check the door. These systems are really cool. You can link them up with a camera system so that if something happens on a door, it can bring up a view of that exact camera. Do it. It's definitely worth it. Document not only where your badge readers are, but where those remote power supplies are, where the batteries are. Check those batteries. After 3 to 5 years is usually when you replace them. They're typical UPS batteries. They're really cheap from Home Depot. If it's in a hot room, then check them replace them every 3 years. If it's in an air-conditioned room, replace them every 5 years. And then I haven't gone into any bypasses, but there's lots of that stuff. So come to the Physical Security Village. We've got all kinds of demos set up there for you to take a look at. I have an RFP on my GitHub. This RFP has everything. So feel free to look at it, pick and choose the stuff that's important to you to put in your RFP or to talk to your project manager about to build the system the way that you think it should be built, but don't accept the defaults because the defaults are never good. Thank you so much. I really appreciate it.